Okay, back for part three. So, what we have now is something very similar to the carbon cycle. We have plants on one side, animals on the other. But instead of exchanging two gases, what's happening is we're sending nitrates this way, nit- um, ammonia comes out and has to be converted to nitrates again. So we have the circle going on here while the nitrogen is being pumped into the ground over here. So there's this cycle here going from the air back to the air, back to the air, and there's a second circle going on here. So this is what I mean. It gets quite a bit more complicated than the carbon cycle. But we have plant to animal to sort of decomposers back. And then we have input from the atmosphere that is undone. Otherwise, there'd be no nitrogen left in the atmosphere. So here's our complementary process, meaning the one that complements it, that it's the equal and opposite of it. So this would be the full extent I'd expect you to be able to explain to me. Nitrogen comes in from the atmosphere with one of two ways. It gets transferred as nitrates to the animals. Ammonia comes out and has to be turned back to nitrates for the plants to use. And that sounds all darn and good until we get to what we do. And this is the problem we've created. Three different ways we've disrupted the nitrogen cycle. First of all, animal waste decomposition products are full of nitrogen compounds, nitrates, and ammonia. And you saw the picture of the pig farm. Untreated human waste, even treated human waste, if they don't get rid of the ammonia and nitrogen, it will fertilize everything that it hits in the water. And the things that grow the fastest in water are not pretty water plants, they're stinky algae. Secondly, we deliberately add fertilizer to the land. Planet Earth would not have 6 billion people on it if we had not discovered fertilization. We run out of fertilizers, we will starve en masse. We need huge amounts of fertilizers, but they put so much on the land, they flood the waterways and fertilize all sorts of stuff. They become pollution. Finally, nitrogen, as I said, can be turned into nitrates with the power and heat of a lightning bolt. Well, you got 48 of those underneath the hood of your car. The internal combustion engine works by compressing air and detonating it under high pressure. And even though your car breathes air just like you, 80% of the gas that gets inside the car engine is nitrogen. When that piston compresses it and the spark is added in, that explosion will ignite the nitrogen as well. So your car kicks out a lot of NO3 out of the tailpipe, which is a gas, and it will turn into acid rain and will also add not just acid rain, which is bad, but also is a source of, again, atmospheric nitrogen compounds that can get to the ground and cause harm. So, what happens when this excess nitrogen gets into the environment? Well, here's a lake right now. That's what it looks like when someone dumped green paint into the water. This will super fertilize the algae. Okay. And this actually causes oxygen depletion of the water. And this is the kind of statement that was made when I was in grade 7 or 8, that I would feel stupid and not raise my hand because the teacher would say, well, see, there's too much fertilizer in the water. That feeds the algae, and the algae chokes out all the air in the water, and the fish die. And that was in the textbooks I grew up with. And my brain was like, but I thought green plants make oxygen. So wouldn't the algae put even more oxygen in the water? And so sometimes when you're not understanding things, it may be the explanation is incomplete. Here's what happens. If you own a fish tank, you get the air in the water by stirring the water up with a filter, little waterfalls. When the algae blankets the water, any oxygen it's making is at the top and it's going up into the air. And the wave action, this water can get so soupy that the wave action stops. So a lot of the oxygen in a water body just goes straight through the water layer. And now it can't, it's covered. But remember, decomposition is the same as respiration. This algae will die later in the season and it will sink to the bottom and rot, and it will consume any remaining oxygen in the water and flood the water with CO2. This also may be an inedible form of algae that none of the fish can live off of. So the entire water food chain dies because the little fish were living on plants on the bottom that are now in pitch black. So what happens is the textbooks do incomplete explanations of this effect, and you're left feeling dumb because you're not understanding how green plants can take oxygen out of the water. So that's one of its effects. These algae blooms may include bacteria and algae that are toxic to life, particularly called blue-green algae. Every year, even in Ontario, there are cottage areas where the lakes bloom with algae, and people are told, don't drink the water, don't swim in the water, don't cook with it. Orangeville is just off the map of Lake Ontario to the top right here. London, Ontario is around here. I grew up in Windsor. This is Leamington, the farthest southernmost point in Canada. This large green patch in Lake Erie, you can see where it's coming from. It's fertilizer runoff on probably the Ohio River or one of the rivers from the States. And this is a giant algae bloom in the lake. And it will deprive all the oxygen there, totally change the ecosystem. So we get them more and more because of we dumping fertilizers in there. In your own home, you have seen the nitrogen cycle when you run a fish tank. If the fish tank is not running correctly, it begins to reek like baby pee. And eventually, algae starts to grow because there are nitrates accumulating in the water. And you have to get rid of them by changing the water. So, to get rid of the ammonia, you have to introduce the bacteria that will turn ammonia over to nitrates. And then once they're nitrates, they'll begin to fertilize the snot out of the tank and fill it with algae unless you change out the nitrates. Or you use a massive tank and you have a massive amounts of plants. There are several videos here you can see about balancing a fish tank. Next time you go to that lovely fish tank at Dairy Queen, it's always in immaculate condition. There is somebody balancing that nitrogen cycle. Fish excrete more ammonia out of their bodies than land dwelling animals. And so it can get really tough to balance the ammonia and nitrate levels in a fish tank. And if the tank begins to stink, it's out of balance. So you'll typically buy nitrifying bacteria when you open the fish tank. If you're changing the water out and cleaning the filter, you can always save a cup of water from the old tank. So when you put fresh water and you dump the dirty water back in, so you keep these ammonia depleting bacteria without having to go to the store and buying another bottle of them. Now, the rest you can read on your own, these blue pages. But one I want you to pay attention for, these are nitrogen compounds from cars in the atmosphere. And this is in China and Indonesia. They call it the Asian brown cloud. It's visible from space. And this is the most populated part of the world, but this is what the air looks like from excess nitrogen compounds. If you are driving towards Toronto in the summer heat, you will see a faint trace of this brown cloud over Toronto. We are doing the same thing here. We are using so many cars, creating so many nitrogen compounds. We are changing the appearance of Earth's atmosphere. This stuff is toxic to inhale, and putting a rag over your face won't stop it. We have got to get rid of our cars. They're destroying the planet's atmosphere. We need to leave the internal combustion engine behind. We are fertilizing our world to death. More on the algae blooms and that in class where it's a lot easier. But this is the basis